Magandang araw po sa ating mga manonood. Ako po si Ian Tabor para sa Afalio Network mula sa 1DLM ng Departamento ng Legal Management sa San Beda University. Narito ako ngayon upang mag-ulat ukol sa mga ganap ng teknolohiya sa larangan ng medisina sa ating bagong segment na Developments of Medical Technology. So unang-una sa lahat, magsisimula tayo sa antiquity o yung mga ganap sa medisina noong 3300 BC hanggang 420 BC. At ang simula nito ay ang prehistoric medicine na nagsimula noong 3300 BC. So prehistory generally means the time period before information began to be written down. The medical practices of prehistory are only known to the people today because of anthropological and archaeological studies, and there are many unanswered questions. Bones from excavations in different parts of the world show signs of broken bones that were set, dental work, and even some surgical procedures. The shamans or medicine men of most prehistoric societies were responsible for maintaining the health of the tribe, and they would practice not only natural remedies from disease and pain, but supernatural ones as well. So kahit hindi natin alam dahil wala silang mga nakasulat dati, ay nakita naman natin ito sa mga anthropological and archaeological studies. And makita natin na hindi lang natural remedies yung mga ginagamit nila, kung hindi rin yung mga supernatural remedies na gamit ng mga shaman nila o yung medicine men nila. Prehistoric peoples were likely limited to only using their local resources to heal wounds and treat disease. Based on the bones of some prehistoric people, researchers can determine that certain herbs were used to treat wounds and improve immunity against disease. Some bones show evidence of being set in hardened, molded clay casts after they were broken. Some prehistoric people show evidence of being knowledgeable about dentistry, with drillings into their teeth being dated back to as long as 6,000 years ago. So makikita natin na kahit hindi nila naisulat yung kanilang mga findings sa larangan ng medisina noong panahon na yun, they were very advanced na sa kanilang age na kaya nilang mag-cast mga nabaaling buto, meron silang kaalaman sa dentistry at kung ano-ano ba. At nakita rin natin ng mga ating researchers, mga archaeologists at anthropologists na yung mga herbs na ginagamit nila sa panggamot ng sugat nila. Women were often the individual caretakers responsible for the health of their family members, and they would have learned about the helpfulness of some plant and animal matter to treat disease, ease childbirth, and nurture wounds. The average life expectancy of a prehistoric person was about 30 years, and the rate of women and children who died in childbirth was much higher than today. Men often lived longer because as hunters, they had greater access to nourishing food. However, men often sustained more injuries during hunting, and their bones show that these wounds were more likely to be fatal than the wounds sustained by women who did not hunt. So makita natin na hindi lang yung mga kalalakihan, yung naging mga shaman, ganyan, yung mga naging engrossed sa larangan ng medisina sa panahon nila. Kung hindi pati, especially mga women, when it comes to childbirth, yung treating disease, nurturing wounds, sila yung mga pinaka naging active dyan dahil sila yung mga naging individual caretakers. E makikita natin na dahil mas naging hunters ang mga kalalakihan noon, ay mas mahaba yung buhay nila kumpara sa 30 years life expectancy ng prehistoric people noong panahon nila. E makita natin yung mga kalalakihan, since sila yung mga laging nag-hunt, laging lumalabas na kanilang kanilang mga tirahan, ay sila rin yung mga laging nagsusustain ng injuries. Yun nga, yung sa bones nila, ganyan, yung mga wounds, and yun. Dumako naman tayo 300 years after sa Ayurveda, which is dated in 3000 BC. So Ayurveda, a natural system of medicine, originated in India more than 3,000 years ago. The term Ayurveda is derived from the Sanskrit words Ayur, meaning life, and Veda, meaning science or knowledge. Thus, Ayurveda translates the knowledge of life. Based on the idea that disease is due to an imbalance or stress in a person's consciousness, Ayurveda encourages certain lifestyle interventions and natural therapies to regain a balance between the body, mind, spirit, and the environment. So alam naman natin lahat na yung mga Indians na kababayan, mga Indian people, ayan, living in India, even way back 3,000 years ago, 3000 BC, makikita natin na sila yung nagpa-unlock ng Ayurveda o yung kanilang sistema ng medisina. Ayun, makita natin sa picture na very centered sa mga herbs nila, ganyan, sa mga napupulot sa kanila. And then yung ginagamit nila na as main means of medicine, dati naman, sa mga panahon naman nila, wala pong masyadong groundbreaking research sa medicina. And ito yung the best that they can do in aiding those who are hurt in their communities. Ayan. In 1500 BC naman, dito na ginagamit yung saffron as medicine on the Aegean island of Thera in ancient Greece. So the history of saffron cultivation and usage reaches back more than 3,000 years and spans many cultures, continents, and civilizations. Saffron, a spice derived from the dried stigmas of the saffron crocus, has remained among the world's most costly substances throughout history. With its bitter taste, hay-like fragrance, and slightly metallic notes, saffron has been used as a seasoning, fragrance, dye, and medicine. Saffron is native to Southwest Asia, but was first cultivated in Greece. So makikita naman natin, base sa description, ito nga pala yung saffron, guys, yung red na ganto siya. So hindi naman siya masyadong, siguro na-encounter natin since this is native to Southwest Asia and mas una siya i-cultivate sa Greece. So ito yung ginagamit nila ay nga pang dye, pampabango, pang seasoning, pero ginagamit nila ito as medicine. And ito yung mga ginamit ng prehistoric people as well as Ayurveda. Sila yung mga naging prehistoric means ng medicine natin in the ancient times. And for 500 BC, Bianque becomes the earliest physician known to use acupuncture and pulse diagnosis. So sino ba si Bianque? Bianque, also pronounced as Pianchu, Wade Giles Pianxiao, who lived in 407 to 310 BC, so around the 500 BC era, was, according to semi-legends, the earliest known Chinese physician during the Warring States period in China. He was also excelled in pulse taking and acupuncture therapy. So ano ba acupuncture? Acupuncture involves the insertion of very thin needles, katulad na nakita natin sa ating screens, and through your skin at strategic points of your body. So a key component of traditional Chinese medicine, acupuncture is most commonly used to treat pain. Increasingly, it is being used for overall wellness, including stress management. So traditional Chinese medicine explains acupuncture as technique for balancing the flow of energy or life force known as qi, believed to flow through pathways or meridians in our bodies. By inserting needles into specific points along these meridians, acupuncture practitioners believe that your energy flow will rebalance. So ito naman, so kung sa ancient Greece meron sa saffron, sa India they have Ayurveda, in China they had acupuncture and pulse diagnosis, which was pioneered by Bianque. So ito yung nakita natin sa especially I think this is very familiar sa atin, kasi it was introduced in Kung Fu Panda, if everyone has watched it. And doon nakita natin na ginagamit talaga. It's a form of traditional Chinese medicine na yung mga thin needles sa mga meridians ng katawan natin in order to alleviate stress, pain, or even diseases. And next up, 400-500 BC still, pills were used. So ito nga pala yung mga terra sigillata, ito yung mga sigilyata, ito yung mga ancient pills natin na ay makita mo, they are made of clay. And yun nga, they are presumably invented so that measured amounts of a medicinal substance could be delivered to a patient. So terra sigillata literally means sealed earth. In the common patterns vernacular, seal probably relates to the waterproof character of the product. But in ancient pharmacy history, terra sigillata refers to the first trademark drug product, a small clay tablet or planche bearing an official mark of authenticity. Katulad nung nakita natin sa screens natin. In this case, the seal was a mark for trade and marketing purposes. So yung mga pre-Christian cultures ingested dirt, but only special dirt, as medicine. Terra sigillata was a rather fatty clay first harvested around 500 BC from a particular hill on the Mediterranean island of Lemnos, now part of Greece. Dug on a special day annually in the presence of governmental and religious dignitaries, the clay was rolled to a defined thickness and pressed with an official seal by priestesses and dried in the sun. Kind of reminds us of Santa Claus o yung isang beer na it's brewed once a year. Kasi yung terra sigillata it is very, hindi lang siya basta-basta kung anong dirt nakita sa ano. It is harvested sa isang special hill sa Lemnos and at a certain date rin. So some early pills still exist in the museums, like this one, consisting of clay from a particular island, yun nga, Lemnos, that was commonly mixed with goat's blood, then shaped into pills. So terra sigillata was supposedly good for practically everything that ails you noong unang panahon, including dysentery, ulcers, and even gonorrhea. Ayan, ito mga hindi natin natakil ay yung 496 to 400 BC ay sinabi na it is not a learned physician who sings incantations over pains which should be cured by cutting. So sinasabi ni Sophocles dito na hindi effective ang pag-i-incant, ang magic sa larangan ng medicine dahil nakikita naman nila, especially in the ancient times, na very crucial and essential yung role ng actual medicine compared to incantations, ito na sinabi niya. And for 420 BC, Hippocrates of course maintains that diseases have natural causes and puts forth the Hippocratic oath, and he is believed to be known as the origin of rational medicine. So for our doctors, for our even medical students out there, ito na nga, kay Hippocrates of course nanggaling yung Hippocratic oath na dapat sa ulado ng bawat medical practitioner. Pero si Hippocrates kasi, and even Galen, sila na yung mga parang kasi they were the border of the ancient medicine papunta sa ating more modern medicine. Now we're in ancient medicine katulad ng mga prehistoric people, katulad ng mga ancient Greeks, ng ancient Chinese. They believed in a lot of superstition, especially yung mga superstition surrounding medicine na yung may mga incantations, ganyan, yung mga iba pinapaniwalaan, instead of actually providing a viable solution. Kay Hippocrates and kay Galen yun nagkaroon ng shift into a more rational kind of medicine. And ito in our screens is a statue of Hippocrates of Kos. Ayan, so tatalakayin naman natin ngayon kung ano nga ba nangyari after Hippocrates and Galen. So ito yung 400 BC to 1161. And ang mga nangyari naman dito sa kanila within that time frame is dahil nagkaroon ng shift from superstition into a more siguro tangible medicinal cure para sa bawat isa, ay nagkaroon ng proliferation ng maraming encyclopedias, maraming academic books pertaining to how physicians, to how doctors, to how educated people will deal with sicknesses. And nakalagay doon dito rin nagkaroon siguro ng parang exponential growth when it comes to the influence of rational medicine as compared to superstitious medicine. Ayan, dumako naman tayo sa medyo, ito na yung mga nakaalis tayo sa superstitions, and dito na tayo mas nag-grow on our scientific findings in the field of medicine. So for 1267, Roger Bacon invents convex lens spectacles for people to read. So in 1267, the English monk and scientist Roger Bacon, who lived from 1214 to 1294, wrote about his experiments in using convex lenses to correct vision, advocating their use to help old people. Convex spectacles seem to have been invented around 1285. So si Roger Bacon yung nagsulat about convex lenses and how using them as spectacles would treat long-sightedness, especially for people their age, yung mga old people in their era. Ano kasi syempre alam natin kahit ngayon, the older you get, the more your vision degrades, and up until this point wala silang nagawa. Kung bulag ka, kung mahirap ka makita, you would not survive in their especially in the prehistoric era, na very very kailangan ang 20/20 vision dahil kailangan makita yung mga hunt mo, kailangan makita yung mga hunt sa'yo. And up until this point, ngayon lang sila nagkaroon ng parang introduction into paano ba malunasan yung mga physical ailments na hindi naman masasagot ng traditional medicine. For the 1300s, we have Alessandro de la Spina invents concave lens. So itong nasa picture natin ngayon is hindi na siya masyadong kasi dati talaga asing seeing stones yung ginagamit nila, pero ito it is fairly modern kumpara sa mga sinaunang ginawa na concave lens spectacles. So the concave lens spectacles were used to treat myopia, and it was developed in Italy. Salvino de Marte probably invented eyeglasses in around 1285. Through various sources suggest an earlier origin. He shared the invention of his new device with Alessandro de la Spina, an Italian monk who made it public and is often credited with inventing eyeglasses. So dito natin nakita na dito mas lumago yung paggamit ng eyeglasses. Historians differ over whether Florence or Pisa was the site of this invention, though it has been considered so important that for centuries, patriotic historians of Italian cities have altered manuscripts and invented evidence to claim the prestige of the invention for their city. Venice became an early center of the mass production of lenses. The glass blowers of the Venetian suburb of Murano produced thicker and clearer glass, better for grinding high-quality lenses than elsewhere in Europe, just as they had produced the best reading stone. So itong mga spectacles na to, it was very popular, especially among Europe, since sa Italia siya na-invent and dun pinalawak. And yun nga, the Venetian Crystal Workers Guild laid down regulations for producing glass discs for the eyes in 1301, and by around 1320, a guild of spectacle makers existed there. So around 1300, siya lang talaga lumago yung paggamit ng spectacles, especially in their day and age. Walang kuryente, mahirap magkaroon ng parang after the sun goes out, pag gabi na, hindi ka talaga makakita kasi sa panahon nila it was very expensive for even candles, wala silang kuryente, for even to use candles na yung royalty lang yung makagamit, hindi makagamit yung mga peasants, and that could have led sa paglabo ng nilang mga mata compared to what we have now, especially me. Lang naman, I have 20/20 vision hanggang ngayon, praise the Lord. Pero yun nga, dito pa lang 1300s lang na imbento ang eyeglass, and hanggang ngayon kitang-kita naman natin na there has been very few improvements, and it has been a staple to our advancing civilization. For the 1500s, Paracelsus becomes the father of toxicology. So Paracelsus, an alchemist by trade, rejects the occultism o yung medicine ng superstition and pioneers the use of chemicals and minerals in medicine. He burns the books of Avicenna, Galen, and Hippocrates. So Paracelsus, he was a Swiss physician. He was an alchemist, he was a lay theologian, and philosopher of the German Renaissance. So he was a German. And he was a pioneer in several aspects of the medical revolution for the Renaissance, emphasizing the value of observation in combination with received wisdom. He's credited as the father of toxicology, and Paracelsus also had a substantial impact as a prophet or diviner. His prognostications being studied by Rosicrucians in the 1600s. Paracelsianism in the early modern medical movement inspired by the study of his work. So Paracelsus, yung naging isa pang siguro Renaissance when it comes to the field of medicine. Na after ng ancient people like Hippocrates and Galen, after them, there comes Paracelsus na asing talaga, lalo niyang idiniin na against siya sa paggamit ng superstitious medicine and it should be translated na lang into the use of chemicals and minerals. Kasi yun naman talaga yung nakapagpagaling. And it is felt even up until to our point. To think na 1500s pa lang ito. Pero yung mga inventions nila, yung mga stand nila is felt pa rin even in our day and age. So malaki tayong jump. 1590, the microscope was invented. And this has played a very, very huge part for our medical advancement. So ang unang nag-invent ng microscope ay si Zacharias Janssen. So every major field of science has benefited from the use of some form of microscope, an invention that dates back to the late 16th century, and a modest Dutch eyeglass maker named Zacharias Janssen, while extremely rough in image quality and magnification compared to modern versions that we have right now. The Janssen microscope was nonetheless a seminal advance in scientific instrumentation. Janssen was a son of a spectacle maker named Hans Janssen in Middelburg, Poland. And while Zacharias is credited with inventing the compound microscope, like what we are seeing right now, most historians surmise that his father must have played a vital role since Zacharias was still in his teens in the 1590s. At that time, eyeglasses was beginning to be used widely among populace. So dito pa lang talagang naging accessible sa masa ang eyeglasses, focusing a great deal of attention on optics and lenses. In fact, some historians credit both the Janssens and a fellow Dutch eyeglass maker, Hans Lippershey, with concurrent though independent invention of the microscope. So kita natin, dito na talaga nagsimula. Dito na yung unang mga hakbang into the advanced medical field that we have in our day and age. Next up, we have 1701, first smallpox inoculations in Europe. So inoculations is another term for vaccinations. And Giacomo Pialarini gives the first smallpox inoculations in Europe, and they were widely practiced in the East before then. Italian physician who became the first to attempt to prevent disease through inoculations by injecting children with smallpox in 1701. By doing so, nearly a century before Edward Jenner's experiment with cowpox, he hoped to save them from the more serious disease that strikes adults. For this, as well as some of his other scientific investigations, Pilarini is considered to be the world's first immunologist. So in our day, especially ngayon, where we are still suffering the effects of the pandemic, dito si Giacomo Pilarini ay ang pinakaunang immunologist sa buong mundo. And even so before 1701, hirap. Pag nagkaroon ka ng smallpox, pag nagkaroon ka ng mumps, pag nagkaroon ka ng anything else, patay ka agad. Kasi wala silang vaccines in order for the body to make to produce antibodies para makalaban sa itong mga malalang sakit ito. And This along with so many other pioneers na iba't ibang vaccines na hindi na natin ma-discuss, paved way to how we live right now, na hindi tayo natakot sa smallpox, hindi tayo natakot sa measles, hindi tayo natakot sa mumps because of what they had done in the previous centuries. So for 1747, we have citrus fruits prevent scurvy. James Lind discovers that citrus fruits prevent scurvy. For 18th century sailors, disease during long sea voyages was often more dangerous than enemy action. One British expedition to raid Spanish holdings in the Pacific Ocean in the 1740s lost 1,300 of an original complement of 2,000 men to scurvy. So to think na out of 2,000 na pinadala mo para, ayun, umano, manlakbay, ang babalik sa'yo, 700 lang. Diba? It is very grabe. Out of 2,000, ano? So grabe talaga. And the commander, George Anson, said almost the whole crew was afflicted by symptoms, including a luxuriancy of fungus flesh, putrid gums, and most dreadful terrors. Many sailors suffered a strange dejection of the spirits and lay immobile, while others who solved to get out of their hammocks have died before they could well reach the deck. So eto, kasi there came a time like it was 100, parang a couple of years, siguro hundreds of years, tinanggap nila na even in the slave trade, tinanggap nila na magkakascurvy itong mga i-import natin galing Africa. So ang ginawa nila, asing pinuno nila ng tao yung mga ships nila, yung mga galleons nila, knowing that the majority of them would die from scurvy, would die from other illnesses. And ito nga, so nag-isip yung mga naval physicians natin. Among the array of imaginative remedies were some that proved effective. Sailors who ate the ship's rats were inadvertently protecting themselves, as those same rats synthesized their own vitamin C. Citrus fruit, another source of vitamin C, had already been suggested as a cure by some. The explorer Sir Richard Hawkins recorded in 1622 that sour lemons and oranges were most fruitful. I wish that some learned man would write of it. More than a century later, a learned man fulfilled that wish with a text which earned him a place in scientific history. James Lind, the person pictured below, also known as the father of naval medicine, was the son of an Edinburgh merchant and became a medical apprentice in the city before joining the Royal Navy as surgeon's mate in the late 1730s. His service allowed him to observe the effects of scurvy at first hand. In 1747, on board HMS Salisbury, he carried out one of the first controlled clinical trials recorded in medical science. He took 12 men suffering from similar symptoms of scurvy, divided them into 6 pairs, and treated them with remedies suggested by previous writers. By the end of the week, those on citrus fruits were well enough to nurse the others. So nakita natin na napaka-significant nito. Kasi especially ngayon, even now that we have seamen, especially for the Philippines, marami tayong overseas Filipino workers working as seamen, napakalaking advancement ng nagawa ni James Lind in naval medicine. Ito na. So 1816, René Laennec invents the stethoscope. René Laennec is a French physician who invented the stethoscope and perfected the art of auditory examination of the chest cavity. In 1816, Laennec was appointed as physician at the Necker Hospital in Paris, where he developed the stethoscope. Laennec's original stethoscope design consisted of a hollow tube of wood that was 3.5 centimeters in diameter and 25 centimeters, like shown in our screens, long, and was mono-aural, transmitting sound to one ear. It could be easily disassembled and reassembled, and it used a special plug to facilitate the transmission of sounds from the patient's heart and lungs. His instrument replaced the practice of immediate auscultation, in which the physician laid his ear on the chest of a patient to listen to chest sounds. the awkwardness that auscultation created in the case of women patients, especially compared lay neck to find a better way to listen to their chest. Na hindi mo na kailangan kasing dumikit ang chest nila para marinig. Kasi up until 1816, ganyan yung ginagawa ng mga physicians. Ayun, his wooden monooral stethoscope was replaced by models using rubber tubing at the end of 19th century. Other advancements include the development of binaural stethoscope o yung imbes na monooral lang, binaural, which means na dalawang ears yung is capable of hearing, capable of transmitting sounds to both ears of the physician. Yan nga. So kay Rene Laennec, nakakatawa siya, he was such a gentleman to think na in-invent niya yung first ever stethoscope dahil na-awkwardan siya sa ginagawang procedures and the method ng dating physicians, especially with women. And nakakatuwa lang talaga. Next up is the 1846, the first painless surgery with general anesthetic. So a young Boston dentist named Dr. Merton had been in the search for a better agent than what had been used by many dentists, nitrous oxide. With Dr. Merton's tenacity, driven by enthusiasm and discovery, he and renowned surgeons at Massachusetts General Hospital, John Collins Warren, made history on October 16, 1846, with the first successful surgical procedure performed with anesthesia. Dr. Merton had single-handedly proven to the world that ether is a gas that when inhaled in the proper dose provided safe and effective anesthesia. So before this, so kahit sabihin natin na nagkaroon na ng anesthesia, ito yung parang pinaka-first successful first painless surgery with general anesthesia. So before, yung mga amputations, yung mga incisions sa katawan, all of that, even with dental work, walang anesthesia. To think na, I mean, even pagtuli, walang anesthesia ng panahon na yun. It was very hard, and this has been a very siguro a great stride, a great advancement in the field of medicine, and it has been the groundwork na ginagamit pa rin sa panahon natin ngayon. So for 1895, ito naman yung X-rays in medical imaging. So a picture right here is Wilhelm Conrad Röntgen, who discovers the medical use of X-rays. So in the year of 1895, Wilhelm Conrad Röntgen, a German physicist, was working with a cathode ray generator. He removed the entire air inside the fluorescent tube and then filled it with a unique gas. When the tube was exposed to a very high electric voltage, it emitted fluorescence. He covered the tube with a black paper and then noticed that a barium-coated screen in his laboratory started to glow. He came to a conclusion that the tube was emitting an unknown invisible light or radiation. The rays reached the deeper layers that were ever expected. He never thought it was possible for the radiation to reach such interior and deeper layers, crossing the denser particles of the material. He was very much attracted and excited about the new phenomena and decided to work on it. It wasn't long before X-rays revealed their dark side, though. Na kahit it is very very beneficial, especially ngayon, kasi ginagamit natin ngayon. At first, no one suspected that the new radiation could be dangerous. But in 1897, initial reports of the terrible effects of exposure to X-rays began to appear: skin burns, hair loss, and cancer. Many tragic cases were reported in the media, and doctors started treating the new radiation with appropriate caution. Nonetheless, the whole human race must be appreciative for this phenomenal innovation. To think now this is one of the medical innovations that happened by an accident. Yung isa pa is penicillin. And nakakatuwa kasi without that happy accident, I personally believe that hindi maging as advanced as what we have right now, especially when it comes to medical imaging and using X-rays as medical imagers. Nakakatuwa lang talaga na it is considered to be a happy accident, ika nga. Next up is 1903 kay Wilhelm Einthoven, and he invents the ECG, or the electrocardiography. Up until this point, the recordings of the heart's electrical activity were crude and the measuring devices cumbersome. Einthoven witnessed a demonstration by Waller at the first International Congress of Physiology in Basel, Switzerland in 1889. Waller demonstrated using his pet dog Jimmy, who apparently sat patiently with his paws in glass jars of saline. Inspired by this demonstration, Eindhoven made considerable improvements to the recording of cardiac electrical activity with a capillary electrometer and introduced the term electrocardiogram at a meeting of the Dutch Medical Association in 1893. 2 years later, in 1895, Eindhoven managed to distinguish 5 deflections using an improved electrometer and a correction formula. He used these deflections, P, Q, R, S, and T, using the mathematical convention dating from Descartes. So yun nga. So Eindhoven's big breakthrough, however, came with his invention of a new galvanometer. So bukod dito, meron din siyang galvanometer in the 1901. This version of galvanometer, which he named the string galvanometer, used fine quartz string coated in silver and weighed approximately 600 pounds. A year later, Eindhoven published the first electrocardiogram recorded on his string galvanometer, and within a year, the production of the world's first commercial ECG machine was well underway. So ito na. It is very ano rin. Ito yung mga very familiar na sa atin, ECG, EKG, na ngayon hanggang ngayon ginagawa natin for the study of our hearts. Ayan, so 1953, John Gibbon ang heart-lung machine. John Hashem Gibbon was born in Philadelphia and was 4th-generation physician. He received his AB from Princeton University in 1923 and his MD from Jefferson Medical College of Philadelphia in 1927. Dr. John Gibbon developed a heart-lung machine that he used in 1953 to successfully complete the first ever open heart operation. Because of the development of the heart-lung machine, surgeons were now able to perform surgeries previously considered to be too risky. Improved versions of the heart-lung machine allow surgeons today to repair heart defects and damaged heart valves and to perform bypass surgery in heart transplants. In 1930, after witnessing the death of a patient from a pulmonary embolectomy, Gibbon conceived the idea of a machine that could support cardiac and respiratory functions at the same time during surgical procedures to repair defects in the heart and the lungs. Over the next decade, Gibbon and his wife Mary developed experimental devices that allowed them to successfully maintain complete pulmonary cardiac bypass in cats for 25 minutes. In the late 1940s, Gibbon persuaded IBM President Thomas J. Watson to provide him with technical expertise needed to produce a more sophisticated device. So ito naman, we're in before 1953, kapag very risky na ang heart-lung surgeries mo, wala na, hindi na magagawa ng paraan. Pero dahil sa innovation ni John Gibbon, yung heart-lung machine, kayang-kaya na ng mga surgeons ngayon na even na ng open heart surgery, nakita natin sa mga shows and even in real life. Next up is 1958. Rune Elmqvist invents the pacemaker. So the first cardiac pacemaker invented in 1952 was the size of a small cathode ray tube television, and the patient had to push around like a shopping cart. Malaki. With the invention of smaller batteries and reliable transistors, pacemakers quickly shrank in size in the years that followed, and as early as 1957, they could be worn around the neck like a pendant. In the same year, Swedish inventor Rune Elmqvist started working on the world's first fully implantable cardiac pacemaker. So ayun, Larson, yung isa sa mga nag-udyok kay Rune Elmqvist and yung kasama niya, went on to receive 25 more pacemakers in the 43 years following the first implantation. A pacemaker restored his ability to swim or cycle or at a leisurely pace, dance, and even travel by plane. He was once again able to meet the demands of working life. Larson held himself up as an example of how successful cardiac pacemakers could be, and successfully lobbied manufacturers to keep up their development activities. He died in 2001, age 86, from causes unrelated to his heart problems on his pacemaker. So yung pagkamatay niya, hindi pa tungkol sa pacemaker, which speaks a lot about kung gaano successful yung pacemaker na ginawa ni Elmquist. Larson even outlived Elmquist, the man responsible for his extended lifespan by around 5 years. So naman, natagalan niya pa yung nag-invent ng pacemaker. And ito na talaga yung asing exponential growth na talaga ng ating ng medical technology. Na from before, pinag-usapan natin yung mga medicine, ganyan yung mga procedure, and this, step by step na nagkakaroon na with the advent of batteries, transistors, mas exponential yung development ng medical technology natin. Next up, 1959 is Min-Chua Chang in vitro fertilization. So, he pioneers IVF. As one of the researchers involved in the development of the oral contraceptive pill, Min-Chun Chang helped to revolutionize the birth control movement. Also, although best known for his involvement with the pill, Chang also made a number of discoveries throughout his scientific career involving a range of topics within the field of reproductive biology. In 1959, Chang was able to demonstrate that eggs from a female black rabbit could be fertilized in vitro by the sperm of a black male rabbit. The fertilized eggs were then transferred to a white female rabbit and result in the birth of a black offspring. This series of steps revealed the potential of an in vitro fertilization and the influence or apparent lack thereof of a surrogate female. Chang also conducted a number of studies on the in vitro fertilization of gold hamsters, mouse, and rat ova. These studies helped form the basis of the in vitro fertilization of human ova by Patrick Steptoe and Robert Edwards, which later led to the birth of the first test tube baby, Louis Joy Brown, on 25th of July, 1978. So, si Mi Chun Chang, siya yung nag-pioneer ng IVF na ngayon it is a viable option for us, for people, especially with those with the means to do so, na imbes na kunyari kung infertile yung isa sa mga partner, partner ganyan, and hindi option ang adoption, this IVF is one of the ways that they are able to propagate the child, na kahit siguro pwede rin gamitin ito kunyari kung hindi kaya ng katawan ng surrogate female, hindi kaya ng katawan ng female partner yung na maging pregnant, kayang-kaya na magkaroon ng surrogate female through IVF. 1963, Paul Winchell invents the artificial heart. Paul Winchell, if familiar pa tayo, he is the original voice of Tigger, so Winnie the Pooh. So Paul Winchell was more well known for his show business career than for his accomplishments as an inventor. So it may come as a surprise that it was this ventriloquist and television series character actor who was the first to design and patent a concept for an implantable, mechanical, and artificial heart. Winchell, though lacking in formal education, was very passionate about a variety of subjects unrelated to the entertainment world, especially in medicine and hypnosis. In 1959, he enrolled at Columbia University. In 1974, he became doctor of acupuncture. And in the 1950s, his acceptance of an invitation to appear on the Arthur Murray Dance Party show would change his life in some respects. That is where he met Dr. Henry Heimlich, the inventor of the Heimlich maneuver, and the two developed a lifelong friendship. After Heimlich invited Winchell to observe surgery in his operating room on several occasions, Winchell had the idea to create an artificial heart that he thought could help keep blood pumping through a difficult open heart surgery procedure so that a person might have a better chance of getting through it in dire circumstances. With the help of advice of Heimlich, when Winchell designed an artificial heart and built a prototype. Ayan yung na-design ni Paul Winchell. And he filed for the patent in 1956 and he received in 1963. Later, when a team of researchers led by Dr. Robert Jarvik began developing an artificial heart concept at the University of Utah, Winchell donated his patent to the institution, and Jarvik, using many of Winchell's basic principles, took the device even further, culminating with the Jarvik 7, the first artificial heart model to be successfully implanted in a human being, Barney Clark, in 1982. Winchell, in fact, invented a number of devices. So, yun. Ayan, to think na even Paul Winchell, without na he was a comedian, he was an actor, he was a voice actor, na he did not have formal education before, pero he had the desire to help, he had the desire to innovate. Siya yung pinakauna-unahang nag-imbento ng artificial heart, which to this day is in very much need ng ating, especially with people with cardiac problems. 1973, Manny Baumick invents laser eye surgery, or LASIK. So Dr. Manny Baumick was born in a mud hut but went on to own marble mansions at Beverly Hills, Bel Air, Malibu, and Palo Verde. Born in a small village in Swiri, Medinapur, West Bengal, India, and thrust into the vortex of a struggle for Indian independence, he almost died of hunger in the 1942 Bengal famine, but went on to wine and dine Hollywood stars and celebrities. Education provided him a way out of the crushing cycle of poverty. He walked barefoot 4 miles daily to school, but went on to become a jet setter and own limousines. He started by lamp at night, but went on to become India's first to receive a PhD in 1958 from the IIT Kharagpur. Receiving a Sloan Foundation Fellowship in 1959, Dr. Baumick came to the University of California, Los Angeles, UCLA, for postdoctoral studies. In 1961, he joined the Quantum Electronics Division at Xerox Electro-Optical Systems in Pasadena and began his career as a laser scientist. As a leader of the team, Dr. Baumick announced a successful demonstration of the world's first ever efficient excimer laser at the Denver, Colorado meeting of the Optical Society of America in May 1973. Subsequently, it found extensive use as the type of laser that made possible the immensely popular LASIK eye surgery, eliminating the need for glasses or contact lenses, in many cases requiring vision correction. So, yung LASIK surgery pala, being invented in 1973, it is one of the more recent innovations na gamit talaga natin ngayon, especially with those who have the means, na imbes na mag-glasses ka, imbes na mag-contact lens ka, magkapa-LASIK surgery ka na lang. Although it is very pricey, it is worth it naman if yun nga, na to think na kayang maayos, makorek yung vision natin through the use of lasers, na to think that our seeing organ, our eyes, are very delicate, very intricate, very sophisticated, to be corrected pa rin by human ingenuity. Nakakabilib, Next up, we have 1985, Yik San Ko invents surgical robot. So a kitchen mixer-sized robot like the one showed there, described as safer and more accurate than a surgeon's hand, has helped doctors remove a tumor in the first application of robotics in human brain surgery. Sa kanya, Dr. Yik San Ko, who developed the computer program that makes the arm work, said the robotic arm is safer, faster, and far less invasive than current surgical procedures, and has a degree of accuracy that no human could hope to match. The hand of the robotic arm holds a probe that guides the surgeon through a hole drilled in the patient's skull and down a narrow tube to the tumor, which has been located by a CT scan. The patient's head is held in place by a frame which contains the coordinates of the target tumor. The robot is accurate to within 1/2000 of an inch. So very, very, very accurate, and gives the surgeon such an accurate picture of the location that he does not have to open a large area of the skull to do his work. The technique means less risk to the patients, doctor said, because material does not have to be injected into the skull to help find the tumor, and general anesthesia is not required. Ayan, so kitang-kita naman natin na ito na nga yung medyo kauna-unahang paggamit ng robot in surgery, in a medical surgery. And kitang-kita natin na kahit si Dr. Yiksan, kung ano yung nagsabi, na yun nga, lalo mas naging accurate, lalo mas naging safe, lalo mas naging um, reliable ang mga surgery dahil sa pioneer niyang surgical robot. So next up for 1996, we have Dolly the Sheep cloned. So ito is yung mga inaral namin kahit nung grade school pa lang kami. So see, Dolly wasn't the first animal to be cloned. Research on cloning had been going on since the mid 20th century, but she was the first example of successful cloning of a mammal from an adult cell rather than a more malleable embryo. To create Dolly, the Roslin Institute team concentrated on arresting the cell cycle, the series of choreographed steps all cells go through in the process of dividing. In Dolly's case, the cells the scientists want to clone came from the udder of a pregnant sheep. To stop them from dividing, researchers starved the cells of nutrients for a week. In response, the cells fell into slumber state that resembled deep hibernation. Ayun. It was a high-risk project, and in the beginning, Dr. Wilmot, along with his team, proceeded with great secrecy, limiting his core team to 4 scientists. His caution proved to be justified. The scientists failed far more often than they succeeded. Out of 277 tries, the researchers eventually produced only 29 embryos that survived longer than 6 days. Of these, all died before birth, except Dolly, whose historic entry into the world was witnessed by a handful of researchers and a veterinarian. Dolly the sheep was euthanized in 2003 after developing lung disease and raising questions about whether being cloned from a 6-year-old ewe made her age more quickly. So ayan, dito na rin yung papasok yung medical ethics na tama nga ba i-clone talaga. Kasi syempre yung pagkukuha naman kay Dolly is with the foresight na i-clone rin sana in the future yung mga tao. Siguro for kunyari kung kailangan mo na ng donor ganyan and wala kang mahappy donor, you can have a clone of yourself as donor. Pero yun nga, dito makita pa lang natin na ang daming trial and error. To think na out of 277 tries, si Dolly lang nag-iisa. So she is a 1 out of 277 odds to have survived. And matagal na research na, and grabe to think na from creating the first microscope, creating the first stethoscope na mga lang, we have come all the way to cloning another living, breathing, carbon-based life form. Next is 1998. James Thomson invents stem cell therapy. So James Thomson is an American biologist who was among the first to isolate human embryonic stem cells and the first to transform human skin cells into stem cells. Thomas was encouraged to work in the biology laboratories where he became interested in the process of early development. The explosive surge of biological activity that occurs when a fertilized egg implants itself in a womb and then begins to divide and form the specialized cells that eventually become the great variety of tissues in the body. Having learned in 1980 that biologists had succeeded in extracting embryonic stem cell from mice, Thomson decided to conduct stem cell research on a species much more similar to humans, the rhesus monkey. After many months of painstaking work, he succeeded in isolating the rhesus monkey embryonic stem cells in 1995. That same year, he was appointed chief pathologist of the primate center. The obvious next step to Thomson was to try to extract stem cells from human embryos. However, this confronted him with a moral dilemma, as such an extraction is fatal to the embryo. After consulting with several bioethicists at the university, Thomson decided that continued research was ethical as long as the embryos created by couples who no longer wanted them in order to have children would otherwise be destroyed. In 1998, he successfully isolated stem cell from an embryo almost simultaneously with research at John Hopkins University. So ito naman yung kauna-unahang stem cell therapy. Kasi ang stem cell, for a quick recap, it is yung bago yung mga embryo, especially yung mga fertilized embryo, mga zygote, bago sila maging specialized cells into and mag-expand, stem cell muna sila. And having stem cell will work wonders dahil kahit pwede mo siya ma-program gawin. Kung ito stem cell, kailangan mo ng bagong kidney, ito stem cell, grow a kidney out of it. Yung mga ganun. And it is very crucial. Kaya nga lang, ang moral dilemma is that harvesting stem cell requires na masira as a whole yung embryo. And an embryo mind you, is already a fertilized egg. Yung mga human embryo, ganyan. And yun nga, given enough time, magiging tao sila. So yun yung naging moral dilemma. And right now, ngayon pa hanggang ngayon, ginagamit pa rin to sa research tungkol laban sa AIDS, laban sa cancer, and all that stuff. So, parang ito yung miracle therapy. 2001, the first telesurgery was performed by Jacques Marcoux. So, yun nga, remote surgery is the ability for a doctor to perform surgery on a patient even though they are not physically in the same location. It is a form of telepresence. A robot surgical system generally consists of one or more arms controlled by the surgeon, a master controller, and a sensory system gives feedback to the user. Remote surgery combines elements of robotics, telecommunications, such as high-speed data connections, and elements of management information systems. While the field of robotic surgery is fairly well established, most of these robots are controlled by surgeons at the location of the surgery. Remote surgery is remote work for the surgeons, where the physical distance between the surgeon and the patient is less relevant. It promises to allow the expertise of specialist surgeons to be available to patients worldwide without the need of patients to travel beyond their local hospital. The first true and complete remote surgery was conducted on the 7th of October 2001 across the Atlantic Ocean with a French surgeon, Dr. Jacques Marcoux, in New York City, performing a cholecystectomy on a 68-year-old female patient 6,230 kilometers away in Strasbourg, France. It was named Operation Lindbergh. So dito palang kitang-kita na natin na parang siyang nakakatuwa kasi kahit ngayon, very especially in our day and age, na very yung telepresence, na kahit hindi kayo magkasama sa isang place, ay you have each other's presence, And the reason why this first telesurgery is very crucial kasi never, it has set a precedent na never before na kahit yung may mga expertise from Europe, expertise from Asia, possible na sila makapag-surgery for a patient that who needs them galing sa US without leaving the walls of their hospitals, and it is grabe from all that we have discussed to this to telepresence na telesurgery, very grabe yung strides in technology. 2007, the visual prosthetic bionic eye Argus 2. The Argus 2 retinal prosthesis system is a 3-part device that allows some perception of light and motion in patients who have lost their vision due to retinitis pigmentosa. Surgery is done to replace a small electronic device on the patient's retina. Later, the patient wears a camera mounted on a pair of glasses and a portable video processing unit. Images are taken in through the camera, processed, and then sent wirelessly to the implant in the patient's retina. The implant stimulates the living cells in the retina, and the brain interprets these patterns as light. Over time, the patient learns to interpret the signals from the Argus 2 to see objects, their surroundings, and in some cases, even read large print text. The Argus 2 is only for patients who have no vision or almost no vision due to advanced retinitis pigmentosa. Patients must pass a careful medical screening to make sure that there are no other physical reasons that they should be given the implant. Patients should be aware that the Argus 2 does not restore complete natural vision. The vision that is required is restored is black and white only and does not include the fine details. So given in this was back in 2007, and given the limitations ng bionic eye, to think na they're able to provide the patient with vision kahit sila ay kahit little to no vision na sila, is a work of wonders. It is, kahit if you would show this to someone living in ancient times, sabihin nila na it is a miracle. And ito yung nakita natin ganda and yung grabe yung stride ng medical technology, especially in our day and age, in the 21st century. 2014, a 3D printer is used for the first ever skull transplant. So 3D printing can solve a great deal of issues, lalo na ngayon sa panahon natin. But this one is huge. In Utrecht, doctors from the University Medical Center have performed the very first full skull transplant with the use of a 3D printer. The 20-year-old woman is now living with a 3D printed implant as skull replacement. This time, the Dutch doctors simply replaced the entire skull, and they were able to do it without any complications because the new skull had been 3D printed in a biocompatible plastic material to perfectly fit the patient's anatomy. The Australian company that handled 3D modeling and 3D printing only had to adjust the CT scan data to remove the added skull growth from the patient's natural bone. Now, these parts can be precisely created using highly precise, customized 3D printing technologies. This not only offers enormous benefits from a purely cosmetic point of view, but patients often have a better brain function seen compared to the old method. Sabi ni Dr. Bon Verwich, yung nag-lead ng UMC Utrecht. So kitang-kita natin na kahit sabi rin nila na yung 3D printed skull transplant has in some degrees been better than yung ibang kinds of transplant. And grabe na we are able in just back in 2014, that's what ilang just a couple of years ago, grabe innovation na we 3D printed that out of a biocompatible material to exactly fit a person's skull. Grabe yung innovation. And for our most recent development in medical technology in 2019, 3D printed heart from human patients' cells. Researchers have 3D printed a heart using a patient's cell, providing hope that the technique could be used to heal hearts or engineer new ones for transplants. This is the first time anyone anywhere has successfully engineered and printed an entire heart, complete with cells, with blood vessels, ventricles, and chambers. Yan, kitang-kita. Sabi ni Professor Tal Devere, yung may hawak, of Tel Aviv University School of Molecular Cell Biology and Biotechnology, said in a statement, the process of printing the heart involved the biopsy of a fatty tissue that surrounds abdominal organs. Researchers separated the cells in the tissue from the rest of the content, namely the extracellular matrix linking the cells, and the cells were reprogrammed to become stem cells with the ability to differentiate into heart cells. So the matrix was processed into a personalized hydrogel that served as the printing ink. The cells in hydrogel were first used to create heart patches with blood vessels, and from there, an entire heart. And we know that cardiovascular diseases are one of the leading causes of death in our developing world. And heart transplantation is one of the only ways to treat end-stage heart failure, and thus highlighting the importance of developing techniques such as 3D printing and others na sa paggawa ng hearts na compatible. So the biocompatibility of engineered materials is crucial to eliminating the risk of implant rejection, which jeopardizes the success of such treatments, he said. Next, the researchers plan to train the hearts to behave like hearts. De Vere explained the cells need to form a pumping ability. They can currently contract, but we need them to work together. So contract, sa pump isa, like what the four chambers of our hearts do. Maybe in 10 years there will be organ printers in the finest hospitals around the world, and these procedures will be conducted routinely. So ayan, we have caught up from way back from 3,300 BC to all the way to the present in 2019 and ngayon 2020 to kita natin. Grabe, exponential yung growth, and whereas it took hundreds of years for us to come from occultism to rational medicine and to the first invention of the microscope, first invention of the stethoscope, to this, to printing, 3D printing hearts from human cells. Grabe. And we know that we only have so much better in store for the future. So this is where our special segment and this news report comes to an end. Kitang-kita naman po natin na kung gaano nakalayo ang narating natin sa larangan ng medisina. Diba? Kasi grabe yung mga pati parang nga, yung sabi ko kanina, yung mga jump is sobrang hundreds of years layo. Pero pagdating sa 1900s to 2000s, sobrang lilit ng gaps and sobrang tataas, sobrang exponential nung growth. So ayun, laging tatandaan, mag-aral na mabuti para lalong makatulong sa kapwa. Muli, ako po si Ian Tabor ng Afalio Network, lagit-laging para sa Bedan, para sa bayan. Maraming salamat po.